Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. This is a live lesson on Year 2 A-Level Maths, Pure Maths. And this is a new chapter. It's differentiation, the chapter on differentiation, building on from what you did in Year 1 and going into some of the more advanced things. First lesson today is how do we differentiate sine and cos? Bismillah ar-Rahman ar-Rahim. Let's begin in the name of God, the most gracious, the most merciful. Sine theta can be differentiated, and the answer to differentiating sine theta is cos theta. Let's just try and understand what that means. That means that if you have the sine graph, and you want to know the gradient at any point, let's suppose you want to know the gradient at this point here, you can tell by eye it's going upwards. It's going upwards quite steeply, probably if it was 45 degrees, that would be a gradient of 1. If it's going 1 square across and then 2 squares up, that would be a gradient of 2. So you can tell at this point here, it's if you drew a straight line, just touching that, being tangent to that, then what's the gradient of that line? And what this is teaching us that if you want to work out the gradient at any point on the sine curve, then all you have to do is type into your calculator the angle that you want to find the gradient at and the cos button, and that will tell you the gradient. So let's try that now. So we want to find the gradient at the value of the degree being 0. So let's type in sine. So this is the sine graph. The value of sine is not what we want. We already know the x is 0, the value of the sine graph is 0. We want to know the gradient of this imaginary red line going like that. So sine differentiates to cos, so it's cos that I'm going to need. So I grab my calculator and I type in cos of 0. On this calculator I have to type 0 and then cos, but on yours probably the other way around. And we get 1. So actually, because the scales were a bit funny here, the gradient is a gradient of 1. So that's exactly 1 square across and 1 square up. What about a bit further up? What would be the gradient at that point there? So we're looking at the cross being here. So the x coordinate, the degrees, the angle, the theta is 90 degrees. And we want to know the gradient here. So just by eye, you can see that the gradient kind of flattens off here because the tangent to the curve there, it's flat. So the answer should really be 0. But let's see what happens. We grab our calculator. The gradient, the differentiation of sine is cos, so we can tell the gradient at any point by using cos. So here we want to type in cos of 90 degrees. So I can type in 90 degrees cos, and you get 0, which is what we were expecting. Okay, brilliant. Let's try it one more time. So let's suppose we are here now. And because it's symmetrical, you can guess that it's going to be very similar to the answer we had here, except this time it's going down. So from left to right, the curve is going down, so the tangent's going downwards. So what's the gradient at this point? That's sine differentiates to cos, so I just need to type in cos of whatever that angle is, which is 180 degrees. So 180 degrees and cos, and it's -1, which is what we were expecting. This one was 1 and this one would be -1. So that's what it means to say that sine theta differentiates to cos theta. And then similarly, if you've got the cos graph, then cos theta differentiates as well. If you want to find the gradient at any point on the cos graph, then the quick way to do it is to use the cos differentiates to minus sine theta. So you have to watch out for this one. The cos differentiates to minus sine theta. Sine theta, you don't need to worry about any minus signs. It's just cos theta. And cos theta differentiates to kind of like sine theta, but you got to remember that minus at the front. Okay, let's work through just a couple of simple examples. Have a think about these ones. If I have y equals 3 plus sine theta, what does that differentiate to? What about y equals 3 times sine theta? What does that differentiate to? And then think about if it was cos instead. So 3 plus cos theta and 3 times cos theta. Okay, hopefully you're looking at the first one and not finding that to be too much of a problem. So we would say dy by dx, the differential of the y equation. Here we would say with respect to theta actually, because there's no x in the equation. So instead of x, we've used theta. So we'd say dy by d theta equals, looking at the first bit, you got a 3, that's just a constant, so that just becomes 0, no need to write anything. And then you've got sine theta, which we've learned differentiates to cos theta. So the answer to that would simply be dy by d theta is equal to cos theta. Next one is hopefully just as easy. Dy by d theta. So here you've got 3 times sine theta. So anything with the times, it just carries through. So in the answer, I'm going to have 3 times whatever the next bit is. And then sine theta differentiates to cos theta. So my answer would be 3 times cos theta. And no need for the times sign in algebra. So we can just bring the 3 close to the cos theta. And it's really the same for the two below, so hopefully you're confident enough to have a go yourself on this one here. Y equals 3 plus cos theta. Okay, as before, the 3 disappears, it differentiates to nothing. Constants, any constant differentiates to nothing when it's a plus or a minus. So then you're left with cos theta, which we learned differentiates to minus sine theta. And that's that one done. Last one coming up. You take a look and see if you can do the last one. So y equals 3 cos theta. Again, times here, so that will follow through. So I'll have dy by d theta. Have a think about that. Okay, 3 times, so the 3 times carries through. 3 times what? Remember, cos theta differentiates to minus sine theta. So be careful, there's a minus there. Minus sine theta. Don't really need the brackets, but I'm just going to put them in there to make it clear. So it's 3 times minus sine theta. And then I can multiply that out, and I'll just end up with the minus and the 3 multiplying together. So I'll get minus 3 times sine theta. Okay, join me for more tomorrow in the next lesson on differentiation. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the mercy and blessings of God.